Let's solve problem 4.11 for Microelectronic Circuits 8th edition by Sedra and Smith. We want to use this rectifier circuit with R equals 200 ohms, and we have a square wave input at VI that alternates between plus 5 volts and negative 3 volts. We want to sketch the resulting waveform V out. Okay, so I think it would be a good idea to sketch V in first. So it's a square wave, and it alternates between plus 5 volts and negative 3 volts right here. And it's a square wave, so it's going to be a horizontal line at 5, jumps down to negative 3, horizontal line, jumps back up to 5, horizontal line, and so forth. All right, now we can start getting ready to draw V out. So first, let's think we have this diode, right? We need to determine what's happening to the diode when Vi is greater and less than 0. So when Vi is positive, well, that means at the anode, we're getting a positive voltage, and at the cathode, we're connected to ground. So from this right side, the diode sees 0. So therefore, we'd be going from positive to 0, high to low. So this diode will be on. It'll be forward biased and it'll behave like a short because it's ideal. Therefore, at this node, we are seeing Vi completely. And this V out is just the voltage drop across the resistor. And because the resistor is connected to ground, it will consume the entirety of Vi. So therefore, when Vi is greater than 0, Vo equals Vi. So we'll get those peaks of 5. But what about when Vi is less than 0? Well, now we have this negative value at the diode. And then on the cathode, we have 0. So we're going from negative to 0, low to high. Therefore, D will be off. The diode will be reverse biased, which means it's consuming all of Vi, which means we have 0 volts at this node. So we're going from 0 volts to 0 volts. Therefore, Vo is equal to 0 whenever Vn is negative. So that just means our curve just only sees the positive peaks. Now, what is the resulting peak and average current through the diode? Okay. Well, as we know, when a diode is off and it's reverse biased, there's no current going through the diode. I equals 0. When the diode is on, we will get current. I equals V over R, which is equal to 5 volts divided by 200 ohms. Make it my calculator. So that is 5 volts divided by 200 ohms. And that is 25 milliamps. So that would be peak. And then the average, right? Let's think about what the graph of the current would look like. So we have 25 here. This is in milliamps. We only see current when Vi is greater than 0. So we just get these positive peaks as well. And it's based 50% positive, 50% 0. So therefore, our average will be 25 milliamps divided by 2, which is equal to 12.5 milliamps. And now the problem's finished.